So let's talk about a different type of decision tree, a classification tree. So classification trees are really similar to regression trees like we've been talking about so far, except classification trees are used to predict a qualitative response instead of a quantitative response. And so now our outcome or our y variable is qualitative, so categorical, instead of being quantitative, like numeric. And so now we're going to predict that each observation belongs to the most commonly occurring class of the training observations in a given region. And so to fit these classification trees, we're still going to use recursive binary splitting, the same as the regression trees, to grow this tree. But instead of using residual sum of squares to determine how well this tree performs, we can use something called the Gini Index. And so what this is basically it's a measure of total variance across the k classes. And so if all of the p hat mk values are very close to 0 or 1, then this is going to be small. And so the Gini Index, sometimes people call this a measure of node purity. And so small values basically indicate that the node contains predominantly observations from a single class, which is what we would want. So we want these terminal nodes at the end to basically, in the most ideal circumstance, if you perfectly separated into the classes, then all observations in a given node would be from the same class. And so in R, this can be estimated using the gain_capture function in the tidy models package. So there's a lot of different words that people use for all these different estimates. And so this gain_capture kind of comes from a different set of language that talks about gain, but it estimates the Gini Index as well. So here's an example. This is using a heart disease data set. And so what we're doing here is we're trying to classify whether 303 patients have heart disease based on 13 predictors. And so these are predictors like age, sex, their cholesterol, and other kind of biomedical predictors. So this is a binary response. It's just yes or no, whether or not they have heart disease. And we've got 13 predictors that are helping us classify them. So my first step is going to be to split the data into a cross-validation set. And so the data set is called heart. And what fold cross-validation do you think I'm doing here? Yes, exactly 5-fold. So you all did great answering this type of question on the midterm. So I think that this is something that most people feel pretty confident in, but essentially this v_folds_cv function, you can dictate how many folds with that v. And so now I'm going to create a model specification that's going to tune based on complexity, alpha, similar to what we were doing before. And so this tree specification is going to look exactly like our previous one, except now our mode, instead of being regression, is going to be classification. And now I'm going to fit the model based on the cross-validation set. And so here I'm still using tune grid. I'm using that tree specification that I just specified where I've set the mode to classification. I have my model. And so here HD is my outcome of interest. And I've got my 13 predictors here that I'm using to predict that outcome. I'm using my grid that looks across different cost complexities, my cross-validation resamples, and then I've added one extra argument here. I've got metrics equals metric set, and I'm setting some metrics. And so this is because by default, R is going to pick certain metrics to try to use to help you pick which cost complexity to decide on. And I'd like for you to add this gain_capture or this estimate of the Gini Index to that list. And so what I'm doing here is I'm saying I would like to look at both gain capture and also accuracy. And so I'm going to see these two metrics when I collect my metrics at the end. So what are the alphas I'm trying here? So I'm sequencing here from 0.01 to 0.05 by 0.1. So I'm trying 0.01, 0.02, 0.03, 0.04, and 0.05. If you're curious about learning more about what this gain capture metric does, you can run !gain_capture in your console after loading the tidy models package, and that will give you a little bit more information about it. Okay, so now I'm going to select my alpha that minimizes that Gini index, And so to use that, I can use the select best function. And I'm going to say my metric now is this gain underscore capture. And then I'm going to pull out that best alpha value. And then I can plug that best alpha value in for cost complexity. So that's what I'm doing here. I still have my mode as classification. This is my final model spec. And now I can fit that final model. Since this is a binary model, I can use a nice heat map to be able to look at the confusion matrix here to see how well this model did. And so I can predict each of the individual classes by plugging in my original data set for new data, and then binding those columns from that original data set so that I can pull in the truth. So I've got the truth here is that heart disease variable, and my estimate is the predicted class from that from my original model. So that's in here as .pred underscore class. And then if you recall from way back, excuse me, at the beginning of the semester, we used this auto plot function to be able to plot these confusion matrix. And so we can do that here. And so this shows here on the diagonal that 143 people were correctly classified into the predict no that were actually not in the heart disease category, and 113 were predicted correctly as having heart disease. And then our missed predictions here were in the off diagonals. Our model predicted 21 folks that did not have heart disease to have heart disease, and 26 that did have heart disease to not have heart disease. So these decision trees, the pros are that they are simple and easy to interpret. The cons are that they're often not very competitive in terms of predictive accuracy. But it turns out that we can do things where we can combine multiple trees that can help us improve accuracy. And so next class, we're going to talk about that, how to combine multiple trees to basically be able to get some improved model accuracy.